Hello. So I have news for you all. It turns out that Python is neither C nor Java. It's not either of those. If that's a surprise to anybody, let me know. It's different than those. So I think the question is, how is it different, that we're going to talk about today. But the reason I want to get into how it's different is that we have a certain responsibility to support our Python as a second language collaborators. So you are the experts, right? You're at this conference, which is a tremendously inclusive conference, which has been great, but of course not everybody can make it, and then a lot of people wouldn't choose to make it. We're the people that were able to get here and really care about this. So either you're an expert already, or in time you're going to be an expert. Before long, you're going to be working with somebody that doesn't know Python as well as you. And the bit of that I want to work on today is specifically when other people are experienced programmers or have experience with another programming language, but they're new to Python. My context for this is that I work at Dropbox, which, as Guido mentioned, is a company that uses a fair bit of Python. So I work with some fairly experienced developers, but a lot of them come to Dropbox without having significant prior Python experience. So what do these folks do? Do they kind of take a dedicated 3 months off when they join to really focus on learning for learning's sake and figure out exactly how Python works and just have a lot of fun while they do it? Well, that would be cool, but that's not what they do. They start learning on the job, right? So we start making progress right away. And that means maybe they'll read some books, maybe they'll watch some talks, maybe they're going to read some blog posts. Maybe they'll ask their colleagues at work, like, hey, how does this thing work? Why was it designed that way? And maybe they're going to Google a lot. That's probably what they're going to do, right? They're going to lots of Google, lots of Stack Overflow. And I think this leaves you with potentially certain blind spots. If the way that you're learning a language is looking up things that are confusing to you, some things don't have pointers. So here are some of the things that might be confusing to folks. Excuse me while I swap my slides for a sec. All right, never mind. We don't need that. I'm looking for speaker notes. I don't need speaker notes. What we can do, we ought to be trying to understand our colleagues' understanding. So this is a big thing whenever you're teaching, whenever you're trying to communicate with another person, figuring out what their mental model of the thing is and providing the right stepping stones to get to where they want to be. So we should try to understand the understanding of people that are coming to Python as a new language, and I'm going to call this Python as a second language empathy. So how do we build this Python as a second language empathy thing? One thing you can do is learn another language first and then learn Python. Who here has another language that they knew relatively well before coming to Python? This is great, terrific. That's a superpower. That's a thing I don't have. I can't ever unlearn Python, learn another thing, and then learn Python. And because of that, I'm missing out. You all have this great experience that, this frame of the world. You have this perspective that I can't have. And I encourage you to use that to help people with a similar background to you. So please use that. If you can't do that, what else could we do? So this is an example of what I want to see. These are talks, right? Django for Salesforce programmers. If you're coming from Salesforce, I would love for you to give this kind of thing, because with that context, it's so powerful to be able to draw, not have to teach Python from the ground up, but say, here's how this is different. Right? This would be another one. I'd love to see this talk. It wouldn't be useful for me because I don't know SPSS, but it would be useful, super useful to a bunch of people. So if you can write this blog post, please write it. Another thing you could do to learn this Python as a second language empathy is learn languages that are different than the ones you know. So every time that you learn a different language, you're learning new dimensions on which someone could have a misconception. Say you've got something like A equals B plus C. Well, depending on what languages you know, you might ask questions like, all right, is that assigning A to the value of B plus C right now, or are we saying that it's always equal and it's going to maintain that equality? Are we going to run B and C, evaluate those expressions now, or are we going to wait until we use A to do that? And I see this A equals. Does that mean we're creating a new variable? Are we setting an existing variable? Does the value stored in A know that it's in a variable called A? When is this code going to run? Is it as soon as I kind of require or import the file or something, or am I going to have to wait for this function to run or something? So these are all thoughts you can have, and they might be ways that someone else is confused. And if you're not familiar with that, maybe it's hard to conceive of how someone else would be misunderstanding. Another thing you can do is listen. You want to listen to questions and notice patterns in them. So maybe you're working with a lot of people that are coming, or grad students, they had been doing R and now they need to do some Python. You want to listen to what are the questions that repeatedly come up. In a general sense, this is what my favorite PyCon speaker, Ned Batchelder, does a wonderful job of. Ned is a saint who, this is him giving a talk here, but he spends thousands of hours in the #Python IRC channel repeatedly answering the same questions about Python. And it's really powerful to see him doing that. And it's amazing that he keeps doing it. It's absurd. He helps run the Boston Python meetup. He does a bunch of stuff. But he's able to coalesce from all this information these really concise, excellent PyCon talks. I think he's given 6 or 7 of them. And I think every single one is an excellent bringing together of all the things that were confusing about something. And I'm going to reference it in some slides coming up, so I had to have the picture here. But one other thing you could do is learn that other language that your colleague knows. And they're trying to learn Python, they're coming from Java. Go learn Java, that'd be great. I didn't really do that. I actually don't know either of these languages very well. But I tried to listen, and I've tried to do some research. And so I want to present to you all some of the things that could be tricky. I've chosen these languages because they're common languages for my colleagues. A lot of times, someone's coming in with a lot of Java or C++ experience. It's very reasonable to assume that a language might work like other languages that you know, because so often they do. They share so much that sometimes when there's a difference, it's surprising. Also, this is not my background, so it was especially important that I kind of study. I wanted to give this talk because I was curious about these things, because now I had to learn them to give this talk. I sort of first learned T181 Basic was my first real programming language, kind of. And I was doing some Excel that my mom taught me, and then it turns out in Starcraft, the old scenario editor, you could write, kind of if-then statements and build complex logic. And then I did a ton of Logo. Logo was the best. That was great. Microworlds was what I was doing in middle school. It was terrific. A little bit of Visual Basic. Got to college, did some Mathematica, and then some MATLAB, and then I took a CS course, and they taught us Python. But my misconceptions about Python were so different than other students who, say, had taken the AP Computer Science in high school where they learned Java. And if you notice, all these languages are similar, and they're all these sort of dynamically typed languages. They all have sort of function, scope kinds of things. They're very different than someone coming from Java saying, where are my types? What's going on here? So it's so important to have that different background or to try to understand it. The other thing is Java and C++ are often taught in schools, is what I found. And so interviewing is another time that this comes up a lot. Someone comes in, and that's what they know. Or just hiring someone right out of undergrad. Okay, so with a little more ado, before I get to the tricky bits, here's stuff that I don't think is tricky. Not that it's not hard, but it's not pernicious. These are misunderstandings that people aren't going to linger with them. Something like new syntax, the fact that you need a colon after a def statement or a for, you get pretty immediate feedback from Python about that. So I'm not too worried about people after their first few days or weeks or months with Python. That's probably not a confusion they'll have. If they see whitespace mattering, you figure that one out pretty quick. Maybe it's hard to get a real good sense of it, but you get feedback. A yield keyword is going to be relatively obvious. There's something to Google there. You say, yield, I don't know what that means. I'm going to Google it. Maybe I still don't understand. I can ask a question. So I'm looking for things that are more pernicious than that maybe not list comprehensions, because list comprehensions look strange and exciting, and so you might go read about them. But these are things that are tricky in other ways. So tricky, I'm going to break down in a few categories. Let's say that we have some things that look similar to Java or C++, but behave differently. Things where there's just a subtle behavior difference. So the first one's scary because you're not going to Google it. It looks similar to a thing you know. The next one's scary because it acts like a thing you know at first, but then turns out different. And then our third are things that are kind of invisible. There's nothing to point you at that says, I better go learn about this thing, because there's nothing in the code file that you're editing. Okay, first up, let's go. Decorators. So these look kind of like a thing in Java. Since I'm teaching you all Java right now, there's a thing in Java called an annotation that you can stick on a method or a class or some other things, and it's a way of adding some metadata to a thing. And then maybe you could do some metaprogramming-ish stuff where you sort of look at those later and make decisions about what code to run. But they're much less powerful than Python decorators. So here we have a Python decorator that it looks like I put in a function and then out came a custom instance of an instance of a custom class called function question thing. Just important to remember that decorators are arbitrary code. They could do anything. So it's the kind of thing somebody coming from Java might miss. They might see what they think is an annotation and say, this is adding some attributes to it that I could probably look up later. Class body assignments creating class variables. This is a big one. We've had some interesting, cool bugs at places because of this. So these are two very different things here, right? Up here, I'm creating a class attribute, and down here, I'm creating an instance attribute. And we have, these ideas exist in C++ and Java. They have slightly different names. You might call it static. But if you see something like the top there, people will assume, oh, I'm instantiating, I'm initializing new attributes on my instance. And that's not what you're doing in Python. So this is something, and it might even appear to work, right? Because it's like, oh, there's something there, but it's shared between all the instances. Runtime errors, not compile time. So here I've slightly misspelled the word print. But this code is valid, it's fine. And I won't even notice anything bad about it until A happens to be equal to 2. So this is something that I think people get, it's not so scary because people do get bitten by it before too long and they get scared of it. And that's that we're not checking nearly as many things at compile time in Python. There's more cases of this. So here I've slightly misspelled value error, but I don't find out until foo actually raises an exception. Or here, until I catch the value error, I don't notice this. And there's some particularly scary bits of this for folks that conceive of imports, as they are in C++ and Java, as a thing that happens maybe before your program runs, right? So what if we were to import some code in here, and once again, maybe we misspell value error, or maybe we don't, but it's just not until we finally get down into this body that we're actually going to run this function and find out, oh, there was a syntax error in the bar module because we hadn't loaded it yet. Or, oh, there is no bar module. That's not a thing. There's no file called bar. We get this information much later than someone from Java or C++ might be used to. And so I think this is something people do figure out because it bites them a few times. But in particular, realizing all this stuff is so dynamic. Here's one that's going to blow your mind, Python people. There's this idea called block scope, where every time you indent, you actually get a new set of local variables. And then when you dedent, those ones go away, and you have your more limited set. People from Java and C++ are really used to this idea. They really expect that when they go out of what they call a scope, which they do curly brackets for, that those variables will go away. But something like this, as Python people, we might know that, oh, of course, down below this for loop, I have access to apple and food. Both of those escape the for loop. This might be a thing we're used to, but I think it sneaks up on people a lot because they're expecting, oh, no, things that are indented are a new scope, like they would be with an if statement or a loop or something in one of these other languages. And I think that's, again, a special case of something that Ned has a great talk about, which is that every single one of these expressions or statements is a way of assigning to a new local variable x. So we knew about x equals, that's obvious. For x in, that's a new local variable x, proper variable in that scope. List comprehensions, that x, it's creating an x local variable. Class and def, those are creating new local variables, right? Here's the assigned one, this is a param binding at the bottom here, with, except, import. Import, if you do that in a function, that's going to be a local variable. You can't access from the global scope. People might be confused about that. They might be confused about why you would import in an if statement in the first place, but then they'll say, like, wait, why is that only accessible in here? In my mind, an import is telling the compiler about where to find code, not run this code, create an object, and then leave it as a local variable in there. Okay, category 2, subtle behavior differences. They're pretty wavy categories. I just wanted to break it up a bit. Subtle behavior differences. Assignment, say you're coming from C++ and you think, oh, clearly when I'm using an equal sign, that means I'm making some kind of copy-ish thing of that thing. No, in Python it's always a reference, kind of like Java. Closures, so both C++ and Java have called lambdas and something or other in Java, respectively. But they have slightly different behavior. Now, C++ is going to be fine because someone coming from there says, oh, it's a lambda. I have to specifically say I want these variables captured by reference and these ones by value. Sorry, I should review closures quickly. Closure, I'm going to call a function that has references to variables in outer scopes. So C++, that's fine. They're just going to get to Python and say, I wonder if that's captured by value or by reference. If I change it down here, is it going to change out there? But if you're coming from Java, you might be confused because they use variables become effectively final. You can't change them in that outer scope. So that's a little scarier because you just assume it would work one way, and it doesn't work that way. GC, it's different. It's somewhere in the middle, right? We have both reference counting that you have with smart pointers or something, and we have GC, and you've got to be aware of this. Python 2 trivia, be careful with del. It doesn't do what you think it might do. It's Python 2, so we don't have to talk about it too much, but check it out if you're using Python 2 and doing interesting GC things. Explicit super. So in both of these other languages, there exist cases where the parent constructor will get called for you. And in Python, that's not the case. You need to be calling super if you're overriding a method, right? So this can get complicated in that sometimes super is a very cooperative sort of thing in Python, right? We have an instance of a class, and that class might have a bunch of superclasses, this tree of superclasses, and if you're trying to run all of them, there's some order in which, called method resolution order, you could kind of climb that tree in such a way that none of the parents get called before their children. And all that works great if every single one of those methods calls super, and then maybe that super comes over here. So I have an example here of, we call this diamond inheritance, which is scary, and we don't like it, where I have a class down here that has an init, and it calls super because it inherits from left and right. It goes up to left. Left calls super. That doesn't go up to base. It goes over to right, and then right is the one that calls up. So that's interesting, different, but the scary bit is if you take away that super there, now we might go to child, left, right, and never get up to base. And so this is a new thing that people might not be used to thinking about. It's like, maybe if there's C++ with weird virtual method stuff, but it's your job to kind of traverse that trail, and people, especially coming from Java and C++, a lot of times they really like inheritance. They're really excited about inheritance. So you can scare them off with this, and maybe they'll prefer composition in some cases. All right, third category, so invisible. Things like properties and other descriptors, it's a little scary to folks from Java and C++, where we use getters and setters to carefully kind of insulate our member variables because we wanted to, validate the access with a getter with a setter, or we want to do some calculation in a getter. We don't do that culturally in Python because we don't have to, because either one of these statements can run arbitrary code, right? And the first one could be a property that's running arbitrary code on access in a getter. The second one in a setter, it could be running arbitrary code. And I call it invisible because unless you're looking at the source code for that class, you wouldn't know this. You might think you're just setting this global variable, or this variable. Attribute lookup is super dynamic in Python, right? So you need to know some rules. This comes especially if you're mocking or in unit testing kinds of things where, like, you're not going to access the instance variable unless there are no data descriptor of the same name in that inheritance tree. Things where someone might expect, I'm going to have this behavior. Setting a variable on an instance is always going to change that attribute. It might do something else, and you have to do it at runtime. There are cases in Java and C++ where you can kind of statically determine what code might get run. In Python, you might need to check all the time. Monkey patching is a thing that we do sometimes. We swap in implementations here, once on an instance and once on a class. That's new to folks. Hopefully when they see it, they'll reconsider everything and be suspicious of all the code they run again, especially in tests when we do this a lot. But it is kind of invisible. Someone else could have done it somewhere else. Maybe they're debugging a funny problem and they just don't see, when is this happening? How does this thing have different behavior? Metaprogramming takes less characters. You can do some stuff in Java, but it's real verbose, and so it's hard to miss. But something, I wouldn't even maybe call this metaprogramming, but dynamically determining which class to create an instance of. Here is the first set of parens, and then I'm assuming that returns a class, and then I'm creating an instance of it with Tom1 here. I think it's easy to miss this if you consider this like pretty out there metaprogramming of dynamically determining which code to run. So people may just glance over it, and it's like, oh, no, there's something interesting going on here. And finally, last invisible category. Again, this is Python 2 trivia. How many spaces is one tab in Python 2? 4. No, fortunately, it's 8. Shoot. So, but text editors are going to format it as 4. So that's scary. This is just a way you can look like a super Python expert in the dark arcane arts of Python 2. Great, I gave you a cheat sheet. You have this information. What are you going to do with it? Well, you could just go teach everyone that doesn't know this stuff about Python. Just teach all of this stuff. Just set up a course. Just go point by point. Like, here's this, here's this, here's this. Now you have no more confusions. I'm going to propose you don't do that. And also don't assume someone doesn't know this stuff. Maybe someone knows 80% of these things. I just want this to be a guide of something that someone might not understand. And then you can be more careful as you go about teaching. If you are, so there's this talk by Sasha Landy that I love about kind of how to go about technical teaching, and I'm really excited about Kenneth's talk tomorrow, right, on teaching. But there's so much to talk about for teaching. Only thing I'll say about teaching is knowledge is power. It's measured in watts. So sometimes a good way to teach something to someone about Python would be like, oh, here's this little 3-line example where Python doesn't do what you might expect it to do. I'm not going to pedantically give you paragraphs about how it works. It's just like, hey, FYI, here's this weird thing, and they can on their own time go reconsider. Code review, though, is what I'm really thinking of with this talk. It's our job to look out for our colleagues, to prevent them from getting bitten by Python's sharp corners, to mix metaphors. There's a great talk by Sandhya Sankaram about, and the talk's not released, but the slides are all you need. The slides are online, and it's a good one for incorporating this information into code review. Code comments. Normally, code comments are about why you did a thing. But if you know you have people looking at your code base that aren't as familiar with Python, maybe you could put something like, hey, by the way, this is how this works, or there's something unusual going on here. But then you might say, Tom, if I'm writing those comments, maybe I should just not use fancy features. Yeah, I guess. Maybe you can just write boring Python all the time. And this is valid, but you can go either way with it, right? I think as a code base grows, maybe this becomes more a thing you do. Maybe the bridging code that Guido was talking about this morning, imagine code that runs the same in Python 2, Python 3, Java, and C++. Syntactically it won't run, but imagine code that behaves basically the same. Maybe be easier to understand that code. Maybe it would be really unPythonic and hard to understand. So this is tough, but just keep that in mind that when you're writing code, there's a large part of the world a portion of developers that aren't going to know Python as well, so you do make your code less accessible. Definitely linters. Folks coming from these languages, powerful linters. You want linters doing all sorts of things for them. Anything that their IDE could do in Java should be at least a linter in Python. I stole a slide from Guido. Look, Python, it's big. Maybe that means that we get to do cooler Python things in the future, and everyone will know Python. Maybe it means that Python's going to be this lingua franca where actually it's about being really clear because everybody can understand Python, and probably a mix of those, and different code bases will be different or whatever. And finally, interviewing, I think, is the time when this is most critical for me, because that's this intense time pressure when it's all about communication between me and another person, and we might not speak the same language. How do we communicate in that situation? And it's really helpful to be able to say, even though I don't know C++, you're using Python because you think we use Python at our company, and you're right, but you're putting in the class body your instance initialization code. I can quickly ask, or I can even just assume, or I can just, get past that point, and we can talk about what we were really talking about. And when I'm interviewing places, and I use some fancy Python thing, it's great to know I'm doing that, so I can say, hey, everybody, or hey, interviewer, so I'm doing this. As you can see, this property thing, it's going to run this code in this situation, because you want to have that model running of what another person thinks your code might do. That's it. Thanks.